Hi, everybody. Today we're going to learn how to factor polynomials polynomials with the value of a equaling 1. So remember, in standard form, a polynomial is ax squared plus bx plus c. So we're going to be factoring polynomials where a equals 1. In order to do this, we're going to use the product sum table. When you're factoring a polynomial, a trinomial, with the a being 1, then we can use the fact that the two numbers that multiply to c will add to b. B and C being the coefficient of x is B, and C is your constant. C stands for constant, easy to remember. So two numbers that multiply to C and add to B. So I use the product sum table. So here's a table, P for product, S for sum, okay? The product is the value of C, and the sum is the value of b. All right. So now we're going to factor. So our first example will be x squared minus plus 6x, let's do, plus 5. Okay. So what do we want? We want two numbers that multiply to 5 and add to 6. So we make our table product sum. The product is the value of C, remember, so that's 5. The sum is the value of B, so that's 6. So now we're going to write the multiples, not the multiples, we're going to write the factors of 5. What multiplies to 5? Well, 1 times 5 does. Well, now let's add those. 1 plus 5. We get 6. That's what we wanted to get. So those are the two numbers we're going to use when we factor. Done. So now the next step is to put our two parentheses. We break up our first term, x squared. What times what is x squared? X times x. Now we look in our table. We have a positive 1 and a positive 5. There's our answer. You can check your answer by FOIL method. Okay, you can FOIL this to check it. So x times x is x squared. X times 5x, times 5 I mean, is 5x. 1 times x is x, and 1 times 5 is 5. When we add like terms, we get 6x. So that is right. Let's do another one. Say we have a squared plus 10a plus 21. So remember that B is 10 and C is 21. We set up our product sum table. Our product is C, so that's 21. And our sum is B, so that is 10. So now we have to ask ourselves, what multiplies to 21? Well, 1 times 21 does. But 1 plus 21 does not equal 10. 3 times 7 is 21. And 3 plus 7 is 10. So we found our answer. Two numbers that multiply to 21 and add to 10. So we put our two parentheses. We break up our first term, A times A, and we put our numbers in from the table. Positive 3, positive 7. Again, you can check by FOIL. I'm going to let you do that, but it is correct. A squared plus 7a plus 3a plus 21, and you get the 10a. Example 3. Say we have r squared minus 12r plus 35. So again, we have to write, we know that our b is negative 12. Don't forget that negative sign in front of the 12. And c in this one is 35. Our constant is 35. So we set up our table, product, sum. The product is 35. The sum is negative 12. So again, ask yourself, what are we looking for? We're looking for two numbers that multiply to 35 and add to negative 12. Well, what are the multiples of 35? 1 times 35, the factors I should say. You could say 5 times 7. But notice when we add them, 1 plus 35, get a 36. So that's definitely not right. When we add 5 plus 7, we get 12. Well, we want 12, but we want our 12 to be negative. So remember that negative 5 times negative 7 is positive 35, because a negative times a negative is positive. But when we add negative 5 and negative 7, we keep that sign, so we get a negative 12. So there's our answer. So again, we go back over, we put our two parentheses, we break up that first term, r times r, and then we put in our numbers from the table, minus 5, minus 7. Example 4. What if we had plus, here we go, c squared minus or plus 10 at c minus 11. So our b is 10 and our c is negative 11. So we're going to set up a table. Product sum. Our product is negative 11 and our sum is 10. So what two numbers multiply to 11? 1 times 11. But it's a negative 11. So one of those numbers has to be negative. I'm going to put the negative with the 1, and then I'm going to check. Negative 1 plus 11 equals positive 10. That's what we want. So that's right. If I had done 1 times negative 11, notice when I add that, 1 plus negative 11, I would have gotten negative 10. That's not what we were looking for. All right, so now I go over and I put my parentheses. I break up my first term, and I put the numbers in from the table. These that worked, remember. So negative 1 and positive 11. Negative 1 times 11 is negative 11. Negative 1 plus 11 is 10. They multiply to the last number and add to the middle number. Do one more. So let's see if we have d squared minus 5d minus 24. Okay, so product sum. The product, remember, we can go over here. B is negative 5 and C is negative 24. So the product is negative 24 and the sum is negative 5. Okay, so now two numbers that multiply to negative 24, and when we add them, give us 5. So you could think 1 times 24 is the multiple. You could say 2 and 12. You could say 3 and 8. Or you could say 6 and 4. All of those are possible answers. Of course, one has to be negative, one has to be positive. Okay, so you could say it doesn't, we can figure that out later. So I'm going to look at those numbers and I'm going to see if when I subtract any of them, I get 5. Not here. Not here. 3 and 8. I want a 8 minus 3 gives me my 5. I want a negative 5. So I want my 8 to be negative. So 3 plus negative 8 is negative 5. If I tried negative 3 and 8, I would have gotten a positive 5. Okay, so there's your answer. But all of those are possible answers. 1 times negative 24, let's say, negative 2 times 12, or 2 times negative 12. One of these would have had to be negative, either the 6 or the 4. So there's lots of choices there. There's double the amount that I wrote because you can switch that negative sign. But you need the one that multiplies to negative 24 and adds to negative 5. So again, we put our parentheses. We break up our first term and we put our numbers from the table. Whoops, it was definitely not a 6. It's a negative 8 and a positive 3. And that's how you factor trinomials where the coefficient of the squared term is 1 using the product sum table.